Hello and welcome to Mr. Tompkins EdTech and my series of walkthroughs for the AQA GCSE Mathematics past papers. This particular video is November 2018, Paper 2, Foundation Tier. Now, with the new specification being new, Grade 9 to 1 past papers are like gold dust, and you should not be watching this video unless you've already attempted the paper yourself under test-like conditions. If you haven't, stop the video now and go and do it first. I'm serious, go. Still watching? That's great. Why not subscribe to my channel so you can easily find it again the next time you want some help with your maths. I have plenty of A-level content too, so make sure you come back and check that out if you're carrying on with your maths next year. Please hit the like button if you found the walkthrough helpful. This really helps out my channel and it makes it much easier for others to wade through all the YouTube dross and find the good stuff. Also, before attempting the actual past papers, make sure you've gone through all the practice sets first. AQA produced 4 sets of practice papers to help students prepare for the new GCSE exams, and I would advise you to work through these before moving on to the actual past papers. Have a look at this video series which gives full walkthroughs for AQA practice sets 1 to 4. If you don't happen to have a copy yourself, you'll find a download link to the practice paper in the description below each video. Finally, feel free to ask questions below. It would be helpful if you include a question number and be as specific as possible. I really appreciate your comments and feedback, and I try to respond to these as quickly as I can, especially around exam times. Okay, let's get into it. Welcome along to GCSE Mathematics past paper walkthrough. This is the November 2018 paper 2 for the foundation tier. A quick shout out to Marion, one of my patrons on patreon.com. If you're interested in early releases of my papers, that's a great place to go and look. Question 1, here is a rectangle. Work out the perimeter. Now, perimeter is if you imagine you're starting it in one corner of your shape and then you walk the entire distance around the edge, that is going to be your perimeter, isn't it? So in this case, it's going to be 7 plus 5 plus 7 plus 5. So my perimeter is those all added together. 7 plus 5 plus 7 plus 5 is 24, isn't it? So it's that one there. Question 2. Circle the number greater than negative 0.9. Okay, so just take care of negative numbers. Greater than will be less negative. So if you're at 0. or minus 0.9 on the number line, greater is actually in this direction, isn't it, where the numbers are going to get less big or more positive, I suppose is another way of thinking about it. Okay, so we're looking for the ones that are, well, smaller negative numbers, aren't we? Which is strictly greater than negative 0.9. So this one is going in the other direction, so it's not that one. Similarly, this one is going in the other direction. 9/10 is the same as 0.9, so it's not greater than. So it's got to be that one there, minus 0.89, which kind of comes in about there, doesn't it? Question 3, simplify 8x minus 3 plus 6x. So here we're collecting like terms. So we've got like terms in 8x and 6x, they're both terms in x, and we've got a constant minus 3 there. So grouping together my x's, 8x and 6x together make 14x, and I've just got minus 3 as well, haven't I? So it's that one, 14x minus 3. Question 4. What is the angle of turn clockwise from southwest to east? Okay, so we've got a partial compass drawn here, north at the top. Never eat shredded wheat. North, east, southwest. So southwest is this direction here, isn't it? That's southwest. And if we want to turn clockwise from southwest to east, that means I am looking for the angle from here around to here, aren't I? Because east is in this direction. Okay. Well, what have we got? The distance between east and north is 90 degrees, and the distance between north and west is 90 degrees. So that's like a half turn, 180 degrees. So really then I just need to work out what this little extra bit is down here. Now that is going to be, southwest is halfway between west and south. So the angle is going to be half of the angle between west and south, which is 90 degrees. So that little part there is going to be 45. And my 45 and my 90 altogether make a 225. So it's going to be that one. Question 5. Lucy works for 37 hours per week. Her weekly wage is £303.40 and she receives a pay increase of 25p per hour. Work out her new weekly wage. Okay. So we've been given her hourly pay increase and we need to work out her weekly pay increase. So weekly pay increase is going to be the 25 pence extra an hour she earns. I'm going to write it as 0.25 because it's pence, times the number of hours that she's working. So she's working for 37 hours. Okay, so we need to work out what 0.25 times 37 is. Tapping that into my calculator, 0.25 times 37, that's giving me £9.25. So she's earning an extra £9.25 then per week. So what's her new weekly wage? Her new weekly wage is going to be, it's going to be her old wage, which is £303.40 plus her pay rise of £9.25. So let's add on to our existing answer. So let's just add on 303.4. That comes out to £312.65. Question 6a, complete the bank statement. So we've got a statement here which has got a few entries into it. We've got date, description, credit, which is money being paid into the account, and debit, which is money going out of the account, and then our running balance down the side. So we start off the month of September with £1,140.79 in the bank. So the first thing that then changes is that car repairs happen on the 6th of the month, and that costs £256. So we can work out our new balance by taking our old balance of 1140.79 and subtracting the debit of £256. Okay, that's coming up for me on my calculator as £884.79. 884.79. Okay, then a bit later on in the month the gas bill is due, and that it costs £87.31. So let's subtract that again from our running total. So subtract 87.31. That is giving me 797.48. 797.48. And then salary is paid in on the 24th of the month. So her salary is £2,069.75. So that is a credit into the account. So we need to add that one in. So plus 2069.75. That gives me a total of £2,867.23. Part B says, write down the meaning of debit as used in the bank statement. Okay, so debit here is a payment, isn't it? So we had to pay for car repairs, we had to pay for a gas bill. So it's a payment that is withdrawn from the account. Okay, so debit means a payment coming out of the account. Question 7. Line AB is shown on the grid. A is the point 0, 2. I'm just going to add that onto the diagram. 0, 2. And B is the point 6, 5. So that's 6, 5 up there. Okay. So work out the coordinates of the midpoint of the line AB. So the midpoint is somewhere halfway down between those two values, isn't it? So it's going to be somewhere around here. Okay, now to work it out, what you have to do is average your x coordinates and your y coordinates. So taking my x values, 0 and 6, let's add those together, 0 plus 6 and divide by 2. 0 plus 6 is 6, 6 divided by 2 is 3. So that's the x coordinate. So that's going to be 3. And do the same with the y coordinate then. So I'm going to take my two y values, 2 and 5. We're going to add them together and divide by 2. Essentially you're averaging them out, aren't you? 2 plus 5 is 7. 7 divided by 2 is 3.5. So the coordinate of the midpoint is 3.5. Part B says C is another point on AB. C is closer to B than A. The coordinates of C are whole numbers. Work out the coordinates. Okay, so we're told that C is closer to B than A. So the part of the line which is closer to B than A is this part up here. Okay, and the coordinates then that are whole numbers on that section of the line, well, you've got two to choose from. You've got that one there, or you've got B itself up there. Okay, let's assume it's not going to be B. I'm going to go for that one there. Let's say that's C there then. So that's at the point 4, 4. Okay, and then part C says, on the grid, draw a line from 0, 0 that is parallel to AB and 2/3 as long as AB. Okay. So you'll notice that from this point, this end point to this end point, this line goes along how many squares? 6 squares. And it goes up 3 squares. Okay, so we're going to do 2/3 of that. So 2/3 of 6. 6 divided by 3 is 2 times 2 is 4. That's going to be kind of this length, isn't it? 4 units across. And 2/3 of 3, the vertical distance, 3 divided by 3 is 1 times 2 is 2. So it's going to be like that, isn't it? So 4 units along and 2 units up. So starting from 0, that point there, going 4 units along and 2 units up, it's going to take me to there. Okay, so just going to get my ruler out and then join those 2 points up. Okay, so you can see it's clearly parallel to my original line, and it's 2/3 of its length. So that's good. Question 8. Lena is at the gym. Part A says she will use each of these pieces of equipment once: a row machine, a stepper, a treadmill, and a bike. Lena will use the row machine first. List all the possible orders in which she could use the 4 pieces of equipment. Okay, so we know she must start with the row machine. So let's just go through and write down the other possibilities after that. So she could then go and use the stepper, the treadmill, and then the bike. Okay, I'm just writing it down in the order that they're on there on the page. Now, keeping R the same, let's also keep S the same and switch around B and T. Okay, so that's another possible combination. Now there aren't any others that then start with R and then S. So let's try starting with R and switching the S out for the T. I'm going to get RTSB and then switching the SB around. RTBS. Okay, so they're all the combinations that start with RT. Now, what about if we instead started with RB? RB. Then I could have ST, or I could have RBTS. And I believe that's everything. So I don't know if you noticed, I've been quite systematic about the way I've gone through and switched these around. You have to be quite systematic, otherwise you'll miss out solutions. So I've managed to find 1, 2, 3, 4, 5, 6 different ways she could use the 4 pieces of equipment, given that she uses the row machine first. Part B is the same scenario, totally different sort of question. Part B says the table shows how long Lena spends on each piece of equipment. Lena starts rowing on the row machine at 1:50 p.m. She has a break for 4 minutes between each piece of equipment. What time does she finish on her last piece of equipment? Okay, so 15 minutes, 13 minutes, 35 minutes, 1 hour and 30 minutes. Now we need to add those up, but of course we need to add in these extra breaks as well. Okay, so how much time is it going to take? If I put a 4-minute break in there, and a 4-minute break in there, and a 4-minute break in there, then how many minutes is that and hours altogether? Let's add that up. Okay, so I've got 15, 13, 35, and my 3 4s. So let's just quickly total that up. 15 plus 4 plus 13 plus 4 plus 35 plus an hour and 30 minutes, or plus 4 plus an hour and 30 minutes, which is an hour is 60 minutes. 60 and 30 makes 90, doesn't it? So add on another 90. So that's a total of 165 minutes, which is, if you think 60 minutes is an hour, 2 60s is 120, so that's 2 hours and a remainder of 45 minutes. So 2 3/4 hours then, isn't it? Okay, so if she starts then at 1:50 and 2 hours and 45 minutes is going to pass. So starting at 1:50, adding on 2 hours will take you to 3:50. Adding on 10 minutes of the 45 minutes will take you up to 4 o'clock, and adding on the rest, which is another 35 minutes, which takes you to 4:35 p.m. then, doesn't it? Okay, 4:35. Question 9. The table shows the number of messages Sam receives each day for 5 days. Okay, so we've got a number of emails and a number of texts that she's received, or he. Sam draws a composite bar chart to represent the data. Oh, it's a he. He has drawn the bar for Monday. So you can see the darker bar is the number of emails and the lighter part is the number of texts. And it's a composite bar, so each is drawn on top of each other. So we need to complete the chart. Okay. So Monday's done. Tuesday's emails 8, texts 6. Okay, I think I'm going to cheat and draw shapes for this. So bar at 6. And what's that? Oh, sorry, that was 8 and 6, wasn't it? Okay, and I'm going to shade the bottom part of the bar to show that they're darker. And leave the top part unshaded, I think. Obviously can't use quite the same colours that the examiner has used here, but that will do. maybe I can just show that I've used that key and that key. Now part B says, in total, what fraction of the messages were emails? So if you want to do a fraction, we need to know how many emails there were and what the total was of all the communication. So let's just add up these together then. So number of emails then is going to be 12 plus 8 plus 10 plus 6 plus 12, which is 12, 20, 30, 36, 46, 48. So number of emails adds up to 48, and the number of texts is 5, 11, 14, 20, 24. Okay, so we've got 48 emails and 24 texts. So number of emails is 48 and texts is 24. So then the fraction that are emails is going to be the number that is emails, which is 48, divided by the total. It's these two added together, isn't it? So 48 and 24 gives you a total of 72. Okay, so 48 out of 72. Now your calculator can do the simplifying for you. It's the calculator paper, so just type in 48 divided by 72. That will cancel it down for you. It's 2/3. So that's my final answer, 2/3. Question 10. Each side of a square is made 3 times as long. What happens to the perimeter? Circle your answer. Well, let's just give an example. If I had a 2 by 2 square, so each side is 2, that would have a perimeter of 2, 2, and 2. That's going to have a perimeter of 8. Now if I take each one of those sides and I multiply it up by a factor of 3, that would be 6, 6, and 6 then, wouldn't it? So the perimeter would be 24. So from 8 to 24, it's 3 times as big. Okay, so it's still that one there. Question 11. Here's a list of ingredients to make 6 pancakes. You need 120 grams of flour, 2 eggs, and 210 milliliters of milk. Complete the list of ingredients needed to make 9 pancakes. So in order to move from one table to the next, our 6 pancakes to our 9 pancakes, we use what's called the unitary method. So we work out how much we need for 1 pancake first. So we take our ingredients for 6 and divide everything by 6, and then we can times it by 9 to work out how much we need for 9. So flour was 120 grams, so divide that by 6 is going to give me 20, and 20 times 9 is going to give me 180. So we need 180 grams of flour. 2 eggs, that's not quite so easy to see, but if I do take 2, divide it by 6 times by 9, you'll see it comes out to be 3. So I'm going to need 3 eggs. And 210 divided by 6, again just going to do that on the calculator. 210 divided by 6 times by 9 is 315. So 315 milliliters. So that was eggs and that was grams. Yep, happy with that? Right, so 11b says convert 210 milliliters to fluid ounces. Use 1 fluid ounce is 28.4 milliliters. So this is the amount we want to convert, and this is the formula we're using. It's like 1 to 28.4. Now the one we're trying to convert is on the many side. We're going to the 1 side, so we need to divide here. So to work out the answer, it's going to be 210 divided by 28.4. That will tell me how many fluid ounces I need. Now I need to give the answer to 1 decimal place. So 210 divided by 28.4. That's giving me 7.39. So I'm going to round up to then 7.4. Oops. 7.4. 7.4 fluid ounces. Question 12. Reflect shape A in the x-axis. Now the x-axis is this axis here, so that's going to be the mirror line then, isn't it, that we're going to do the reflection in. Now don't try and reflect the shape, reflect the vertices of the shape, the corners, and then draw your lines between the corners that you have found where they lie. Now for each corner you just need to find how far away it is from the mirror line and then plot it the same distance on the other side of the line. So that corner there is 1 unit away, so it's going to end up there. That one is 1 unit away, and that top corner there is 1, 2, 3, 4 units from the mirror line. So its image is going to be 1, 2, 3, 4 units from the mirror line. It's going to be down there. Okay, once you've finished drawing your points, then you can join them up with a nice straight line. Like that isn't. Let's try that again. Come on, auto shape, do your biz. Okay, that's it. Okay, so that's my image there. Question 13. A charity sends an appeal letter to 3,000 people. The letter asks for a donation of money. Here is some information about the last appeal letter the charity sent out. Half the people who were sent the letter made a donation. The average donation was £8.60. A third of the people who made a donation filled in a tax form. The government adds 25% to the donations of these people. Using this information, work out the amount the charity can expect to receive from this appeal. Okay, so it sent it to 3,000 people, so that's important, isn't it? And we know that half of the people made a donation, so using that we can say number of donations is going to be 3,000 times 1/2, which is 1,500. So they're going to be receiving around 1,500 donations. The average donation was £8.60. So we can use that. So if you added up all the donations, divide by how many donations it was, and you got £8.60, that means if I times £8.60 by the number of donations, I should get the sum of all the donations. So total donations is going to be 1,500 times my £8.60. 1,500 times 8.6, that comes out to be 12,900. So 12,900. Okay, well now what? A third of the people who made a donation filled in a tax form, and the government adds 25% donations to these people. So a third of the donators is a third of 1,500. So tax form filled by 1,500 times a third, which is 500 people. So they received an extra 25% of donations. So what is 25%? 25% of £8.60. That's going to be 860 times by 0.25 then. What's that? 8.6 times 0.25. That's another £2.15. Okay, so if 500 people filled out a tax form and that meant their donation was added an extra 25%, then tax added is going to be 500 times 2.15, which is 500 times 2.15, 1,075. 1075. So then the total donations received is going to be this amount up here plus this extra bit that we get back from the tax man. So adding those two together, plus 12900 That comes out to be 13,975. Oops. 13,975. 13b says the average donation from the people who filled in a tax form was more than £8.60. How does this affect your answer to part A? Tick one box. It should be lower, it should be higher, it should be the same. Okay, now if you have a look at our calculation here, it is going to be this bit here that then is going to increase. I suppose in a way that this one would then decrease as well, wouldn't it? So if the average overall for all donations is £8.60, but the people who filled out a tax form paid slightly more on average, and the people who didn't fill in the tax form paid slightly less on average, then you might think they're going to cancel each other out, but actually, because this group who pays slightly more, we then add the tax on to the end, overall the amount is going to go up slightly. So I'm going to tick it's going to go up, or it should be higher. And my reason is the amount of donations where the extra 25% tax is added has been increased. Okay, so the proportion of the money that we're paying the extra 25% tax on is increased, so overall the amount of money that is raised is going to go up slightly. Question 14. Lee wants to draw the graph y equals x for the values of x from -5 to 5, and here is his graph. Oh dear. Lee, your graph is a little bit wonky there, isn't it? Make two different criticisms about the graph. Okay, well firstly, the graph should be, this bit over here looks okay, but then it should continue down in this direction, shouldn't it? Okay, so if y is equal to x, then here x is -1, so y should be -1 as well, so it should have points here, here, here and here, and not where he's drawn them. So that's my first criticism. He's got the y values wrong for the negative range. So my first criticism is Lee has incorrectly plotted the points for x, well, for negative values of x. Okay, my second criticism, it says here that you should draw the graph of values of x from -5 to 5. And he's bailed out at 4, isn't he? He should really have plotted that extra point up here at 5, 5, and also another one down here at -5, -5. Okay, so that's going to be my second criticism. Lee has not plotted points 5, 5, and -5, -5. So he hasn't gone far enough, has he? Question 15. A company uses this formula to work out cost A of a taxi ride. So cost A is equal to 4 plus 1.8 times M plus B. £4 is the fixed charge. £4 is a fixed charge, so that's that bit there of the calculation. M is the number of miles travelled, so the miles travelled here is M, so you times that by 1.8. So basically you're being charged £1.80 per mile plus the fixed amount of £4. And then B is the booking charge online, so then you also have to pay that amount on the end. Okay, Doesn't say what the booking fee is at the moment. Maybe that tells us later on. 15A says Claire books a taxi online and travels 8 miles. So this is going to be the value for M, isn't it? She pays £20 altogether. How much is the charge for booking online? Okay, so A, this is A, isn't it? We've been given the total altogether. We've been given the number of miles. 4 is a fixed number, B is a fixed number, so we should be able to work out B from here. Let's just sub in what we know. So A equals 4 plus 1.8 times M plus B. Okay, so what do we know? We know A is £20. We know that M is 8. We don't know B. That's what we need to find. Okay, so I've got 20 equals 4 plus 1.8 lots of 8 plus B. What's 1.8 times 8? 1.8 times 8 is 14.4 or £14.40. So that's 20 equals 4 plus £14.40 plus B. Let's just add these bits together first. So 20 equals 4 plus 14 is 18, so that's £18.40, isn't it? Plus B. So now we can subtract £18.40 from both sides. See what we're left with. So 1840 subtract 1840 on the right, they're going to disappear, aren't they? Leave me just with the B on the right hand side. And 20 subtract £18.40 leaves me with £1.60. So that must be my booking fee, £1.60. Okay, now part B says a different company has a fixed charge of £3, charges £1.90 per mile, and has no charge for booking online. Write a formula for the cost C of a taxi ride with this company. Okay, so C then is going to be my fixed charge of £3 plus my £1.90, 1.9 lots of my mileage, which, if you remember rightly, is M. So C equals 3 plus 1.9 times M. What does A intersect B represent in the probability of A intersect B? Circle your answer. Well, I think I've given it away there, really. I'm just decoding what these things here represent. A intersect B, or this symbol here, means the intersection of. It means that an element lies in both sets. So if I had a set A and a set B, then the intersector are where they overlap. So it's that bit there inside there. Okay, so that's what that part there means. It means the intersection of. So A means set A, B means set B, the upside down U means the intersection of. This bit here means the probability of. So it's actually asking what's the probability of an element being in that set. Okay, but the A union B part is it needs to be in A or B or both. No, not that one. In A but not B? Nope. Not in A and not in B? Nope. It's in A and B. It's got to be in both. So another way of reading it is that is and. A circle has a circumference of C and a diameter of D. C equals KD. What value does the constant K represent? Well, the constant, well, normally C, circumference, is equal to pi times diameter, isn't it? So this pi here must be the same thing as that K there. So we're saying, well, I'm saying it's got to be pi. Question 18. There are 240 cows on a farm. Part A says, on a farm, the number of bulls to the number of the cows is 1 to 30. How many bulls are there? So the number of bulls to the number of cows is 1 to 30. So if the ratio of bulls to cows is 1 to 30, but we have 240 cows on the farm, how many bulls is that? Well, what do we have to multiply 30 by to get 240s? 30s into 240 is the same as 3's into 24. 3 goes into 24 8 times, so we've multiplied that or scaled it up by a factor of 8. So doing the same this side, 8 times 1 is going to give me 8 balls. 8. Now, part B says, assume that the 240 cows produce milk for 10 months each year. Each cow produces an average of 25 litres of milk per day. Estimate the total milk production in litres of the 240 cows in 1 year. You must show your working. Now, months, some months have 30 days in, some have 31, some have 28 and or 29 on a leap year. But I'm gonna pick 30 days per month. So I'm going to assume 30 days equals 1 month, because 30 is an easy number to calculate with, much easier than 31. So I'm going to assume 30 days is 1 month, and so production is going to be my 25 litres of milk per day times my 30 days in a month times my 10 months in a year that the cows are producing milk for. So it's going to be 25 times 30 times 10. Okay, so 25 times 30 times 10 comes out to be 7,500 litres. So we know that one cow can produce 7,500 litres, but on this farm there are 240 cows, so the total production of, so that was one cow production, isn't it? And this is total production, 7,500 times the 240 cows, which is 18 and then 5 zeros. 18,000,000. So that's 1,800,000 litres. That's a lot of milk. Question 19. Here is a right angled triangle, and we need to show that x is equal to 12. Okay, so we've got two sides of a right angled triangle, and we're wanting to find a third side. So clearly we are dealing here with Pythagoras Theorem. Pythagoras Theorem states that c squared equals a squared plus b squared, where c is the long side and a and b are the two sides. Okay, so we're just going to sub into there and find what c is, and then say that's what x is. So c equals a squared plus b squared. In this case, c is x. X squared is equal to 7.2 squared plus 9.6 squared. So on my calculator, 7.2 squared plus 9.6 squared comes out to be 144. So then x is going to be the root of 144, which is 12. I'm going to work out the values of a and b in the identity. And I've got 5 lots of 7x plus 8 plus 3 lots of 2x plus 4 is identical to ax plus 13. Okay, so I've got quite a complex expression on the left-hand side of my identity symbol and a fairly simplistic one on the right. Now, when you've got identities, these are not like equations that you have to solve. We're not trying to move things over the equal sign and simplify it down. What we need to do is make one side look more like the other so we can more directly compare them. Okay, so what I'm going to do is I'm going to start off with one side, and it's usually best to start with the most complex of the two sides and make it try to make it look more like the other side so we can more directly compare. So let's start with the left hand side, because that is the most complex. So I'm going to write down LHS for left hand side, and that is 5 lots of 7x plus 8 plus 3 lots of 2x plus b. Okay, So we're just going to work on one side. We're not going to move things over. You'll get confused if you do it that way. So first off, let's simplify it by multiplying out the brackets. So outside the bracket, number outside the bracket gets multiplied by everything inside. So 5 times 7x is 35x, and 5 times a is 40. And the second bracket, 3 lots of 2x is 6x, and 3 lots of b is 3b. Okay. So I've got some like terms here. I've got two terms in x, 35x and 6x. So let's bring that together and make 41x. And I've got 3b plus 40. Now that's all part of my constant, isn't it? So I've got 41x's plus my 3b plus 40. Okay. Now we know that that is equal to ax plus 13. And now we're in a position I can more directly compare them. Let's have a look at this coefficient of x here. The coefficient of x on the left hand side is 41, and on the right hand side it's a. So if we're saying that these two things are identical, then 41 must be equal to a. Similarly, if I know that these two things are identical, then the number part must be equal as well. So my 3b plus 40 must be equal to 13. So if 3b plus 40 is equal to 13, then rearranging that, subtract 40 from both sides, and we're going to get 3b is 13, subtract 40, which is what, minus 27, and then divide both sides by 3. B is going to be minus 9, then, isn't it? Okay, so a is 41, b is minus 9.
Question 21. The first four terms of a linear sequence are 7, 11, 15, 19. Circle the expression for the nth term. Okay, well, the nth term, the n part of the nth term, you can find out by looking at the gap between the numbers. This is a plus 4. No, it isn't. Yes, it is. A plus 4 sequence. 7 plus 4 is 11, 11 plus 4 is 15, 15 plus 4 is 19. So it's going up in 4s. That tells me that my nth term has something to do with 4n. So it's not n plus 6, and it's not that one, and it's not that one. It's going to be that one. Okay, now you can tell it's going to be 4n plus 3 because the sequence 4n is 4, 8, 12, 16, and I've got 5, 11, 15, 19. Now you can see from there to there, each of these numbers is 3 more. So I've actually got the sequence 4n plus 3. But I already knew it was that one because I knew it was going up in 4s, so it can't be the n plus 6 or the 7n plus 4 or the n plus 4. It's got to be 4n plus 3.
Here is some information about 20 trains leaving a station. So we've got a number of minutes late. The first group is between 0 and 5 minutes late. The second group between 5 and 10 minutes late. 10 to 15 minutes late, and more than 15 minutes late. And we can see that 12 trains were between 0 and 5 minutes late. 7 were between 5 and 10. 1 between 10 and 15. And none were later than that. Okay, so you can see that there's a couple of extra columns on that table for us to complete. Now, we're being asked to work out an estimate of the mean of these. So what we need to do is first find the midpoint, which is handily already been indicated here. So the midpoint of a range, you just have to add the two numbers together and divide by 2. So 0 plus 5 is 5, divided by 2 is 2.5. 5 plus 10 is 15, divided by 2 is 7.5. 10 plus 15 is 25, divided by 2 is 12.5. And we don't need to do the next one because there's 0 anyway, so no need to stress about that one. Okay, and then to find the an estimate of the mean, then we need to multiply our f values, our frequency, times our x value, whatever the values are that we've got. Okay, so we're going to use the midpoint as our estimate. So 12 times 2.5 basically. So reaching for a calculator. So 12 times 2.5, that comes out to be 30.
7 times 7.5 is 52.5. 1 times 12.5 is just 12.5. Okay, and then to find the estimate mean, we're going to have to add all those up, aren't we? So 30 plus 52.5 plus 12.5 gives me a grand total of 95. Okay, then, so an estimated mean is going to be sigma fx, the sum of f times x, divided by sigma f, the sum of the frequencies. So it's going to be 95 divided by the sum of the frequencies. 12 plus 7 plus 1 adds up to 20, doesn't it? 20 trains. So 95 divided by 20, 4.75. So we're saying on average there is 4.75 trains. Oh no, 4.75 minutes, isn't it? Not trains. In part B, it says the station manager looks at the information in more detail, and you can see that he's got a more finely divided up categories. So there's more categories. He's doing every 2 minutes now instead of every 5 minutes. And we've got the new distribution in here. Okay, so he works out an estimate of the mean using this information. How does his estimate compare with that answer to part A? Is it going to be higher than part A, the same as part A, lower than part A? Not possible to tell. Okay, so if I look at our new data, I've got 12 trains, which is the vast majority of them, that before I thought were in the category 0 to 5, and now I've worked out in the category 0 to 2. So these are going to have a mid-value of about 1, aren't they? Giving me 1 times 12 there. And then the second category up here, I thought I had 7 trains that were in between 5 and 10 minutes late, give me a midpoint of 7.5. Now I see that those 7 trains are actually between 4 and 6, and the midpoint of those is going to be 5, which is again going to be shorter time than what I was using previously. And again, 10 to 12 is going to have a mid value of 11, whereas before I was using a mid value of 12.5. So it's going to give me a lower score, isn't it? Because I'm using lower midpoint values now. 2 identical quarter circles are cut from a rectangle as shown, and we need to work out the shaded area. Okay, so if these are 2 quarter circles next to each other, then the radius of this quarter circle must be 6 and half of 12. So from here to here must be 6, and from here to here must be 6. Okay, and because this is a circle and 6 is the radius, then this also must be 6, this distance here. So that means the rectangle from which the 2 quarter circles was cut is of dimensions 12 times 6. So then the area, of the rectangle, which I'm just going to draw a rectangle like that, area rectangle, that's going to be the 12 times the 6, which is 12 times 6 is 72. Okay, and then I've got my area of a quarter circle. Quarter circle is going to be, well, the area of a circle is pi r squared, isn't it? Pi r squared, but I've only got a quarter circle, so it's a quarter of that. And we know the radius is 6, so it's pi times 6 squared over 4. So I'm just going to type that just as it is into the calculator. So I'm going to type in pi times 6 squared. Just take care when you're dividing by 4. You don't want to divide 6 squared by 4, you want to divide the whole thing. So if you subtotal 36 pi and then divide by 4, we'll get a quarter of pi, which is it's 9 pi. Okay, so then the shaded area is going to be the area of my rectangle minus 2 lots of the area of the quarter circle. And that is going to be 72 subtract 2 lots of 9 pi. Okay, so 2 lots of 9 pi is 18 pi. So then typing into my calculator 72 subtract 18 pi. That gives me 15.45. Does it ask me to round off in a particular way? Nope. So if it doesn't tell me, I'm just going to round off to 3 significant figures. 15.45 rounds to 15.5, doesn't it? So that's what I'm going to write down. 15.5. The diagram shows the position of a tap when off and fully on. The tap is fully on when the angle of turn is 180 degrees. So when it's pointing up, it's off, and when you turn it around to face downwards, it is fully on. So when fully on, water flows out of the tap at 14 litres per minute. The rate at which water flows out is in direct proportion to the angle of turn. So the tap is turned to 135 degrees and water flows into the tank with a capacity of 79.8 litres. Will it take less than 7.5 minutes to fill the tank? You must show your working. Okay, so this is an interesting direct proportion question. We know that the rate of water flow is in direct proportion to the angle of turn. So let's call F the flow, and let's make T be the turn. Okay, so we know then that the flow, F, is in proportion to T, the angle of turn. Okay, so I'm going to say that F little fishy T, which means is proportional to, then I can replace that symbol of proportionality with equals to K lots of T, like that. So F equals KT, where K is the constant we need to find. Now, normally at this point, we're given two values that go together so that we can evaluate K. Now, the pair of values that we know that go together are that when it is fully on, then the flow rate is 14 litres per minute. And fully on, we already know, is that the angle of turn is 180 degrees. So in other words, our turn is 180 and our F is 14. Okay? So we know that when T equals 180, F equals 14. So let's sub those two values in. So 14 then is going to be K lots of 180, and that makes K 14 over 180 then, doesn't it? K equals 14 over 180. Does that cancel down? 14 over 180 cancel down, well, not very much, 7 over 90. Okay, so then the complete equation then, so we're saying this cancels down to 7 over 90. Okay, so the complete equation for this relationship is F is equal to 7 lots of T over 90. Okay, so now we've got a formula that links F and T together. We can find what F is at T at any given T. So we want to know what the flow is here then when the tap is turned to 35 degrees. What is the value of F at that value? Okay, so we're going to write down when F equals 130. Well, sorry, when T is equal to 135, what's F? Okay, then F is going to be 7 lots of 135 over 90, which is 7 times 135 divided by 90. It's 21 over 2. 21 over 2 is what, 10.5? Okay, 10.5 watts. The units is litres per minute, isn't it? So that's 10.5 litres per minute. Okay, running out of space a bit here. So if the flow is 10.5 litres per minute, let's come back up here then. So 10.5 litres per minute. Will it take less than 7.5 minutes to fill the tank? Okay, will it? Well, the capacity of the tank is 79.8 litres, and it is filling at 10.5 litres per minute. So if we divide one by the other, we'll find out how long it takes. So time is going to be 79.8 divided by 10.5. So what's that? 79.8 divided by 10.5. That gives me 38 over 5, which is the same thing as 7.6. Takes 7.6 minutes. Will it take less than 7.5 minutes to fill the tank? Well, 0.6 is more than half a minute, isn't it? So my answer is no. It takes longer than 7.5 mins. Okay, that's our answer. Now it isn't quite in the right place, but you know, the examiner will find it up there. I think that's fine. Let me just underline it there. Maybe put it in a box. Okay, no, it takes longer than 7.5 minutes. I think I've got all my bases covered. This triangle is equilateral. Is the perimeter of the triangle greater than 1 meter? You must show your working. Okay, so I've been given 3 sides of an equilateral triangle, but each side has been given algebraically, and it's a different algebraic expression. So this one is equal to this one is equal to this one. So that means that those 3 algebraic expressions must be equal to each other. So 6x minus 10 has got to be equal to 4x plus 5, which has got to be equal to 10 lots of x minus 4. Okay? Now it's not so easy to work with like 3 parts of an equation like that. Can't really have 2 equal signs. So probably it's easier to work on one part and then the other part. So let's start with the first 2. 6x minus 10 is equal to 4x plus 5. So solving those, taking 4x away from both sides is going to give me 2x, and adding 10 to both sides is going to give me 15. So I think 2x is going to be equal to 15, making x equal to 7.5. Now if x is 7.5, what is the perimeter of one side? Okay, so let's take one of those calculations for the side, 6x minus 10 for instance. So what would 6x minus 10 be equal to? That would be now equal to 6 lots of 7.5 minus 10. So 6 times 7.5 gives me 45. And then 45 subtract 10 is going to be 35. So that equals 35. So that side is 35, and because these are all the same, that must be 35, and that must be 35 as well, even if they look a bit different. So the perimeter is going to be 35 plus 35 plus 35, which is 105. Is the perimeter of a triangle greater than 1 meter? Well, it's 105 centimeters, and that is yes. So total perimeter is 35 times 3, which is 105 centimeters. So the answer is yes. 105 centimeters is bigger than 1 meter. It's 1.05 meters, isn't it? Now, an approximation for the value of pi is given by this kind of strange formula here. 4 lots of 1 minus 22 over 57 plus 22 over 85 plus minus 22 over 105, etc., etc. Use your calculator to show that this approximation is within 0.1 of 3.14. So basically, we've just got to type that into the calculator and see what we get. Okay, let's do that then. So, calculator, tell me, what is 4 minus 1 minus, I'm going to use the fraction key all the way through here, 22 over 57 plus 22 over 85 minus 22 over 105. Notice I'm using the arrow key to get me out of the fraction when I finish typing in, plus 22 over 117 minus 22 over 242, close bracket. What is that equal to then? So I'm going to write down the full display, 3.0418, 3.0148, what's the rest of it? 39619. 39619. Okay, so show that the approximation is within 0.1 of 3.14. So if I then subtract that from 3.14, I should be able to show what the difference is between the two. So 3.14 minus 3.0148399619. What's that going to be equal to then? So on my calculator, 3.14 subtract, don't want to type it in again, just going to use the answer key. That is 0.0816. 0.9816. Okay, which is clearly less than 0.1. Work out, and I've got two numbers in standard form, 9.12 times 10 to the 10 divided by 3.2 times 10 to the 4. Give your answer in standard form. Okay, now the easiest way to do that is to divide like with like. Now the number part at the front of a number in standard form is called the mantissa. Did you know that? So I'm going to divide the mantissas with each other, and then I'm going to divide the exponent part, which is this part here. So mantissa and exponent it's called. So type in the mantissas in first. 9.12 divided by 3.2. That's going to give me 57 over 2, or 2.85. And then times 10 to the power of what? I've got 10 to the 10 divided by 10 to the 4. I've got numbers with the same base, subtract the indices. 10 subtract 4 is 6. So 2.85 times 10 to the 6.
So that's all. We've reached the end of the paper. How did you do? Let me know in the comments below, along with any questions you still might have. Don't forget to like and subscribe if you found this walkthrough helpful. If you didn't do so well, try revising around the topics you're struggling with before attempting another past paper. Good luck with your preparations and in your exams, and see you again next time.